So with that said, what does software-defined networks do? There's a lot of discussion about software-defined networks. What does it do besides drive open innovation? Well, first of all, one of the key aspects of legacy networks is that they are not automated and they are not simple. There are a lot of experts necessary to run a network. No longer, really up until this time, many experts are necessary to run a large network and maintain that network in a way that enables productivity for everyone connected. And these experts are expensive. They have to be trained in a certain way. They have to know the bowels of those networking devices. They need to understand how to manage them and how to control them and all the little idiosyncrasies and nuances. And so software really has not evolved to enable those things to be automated and those things to enable high productivity and true plug and play. What software-defined networks does, and especially riding over an Ethernet infrastructure, is it fundamentally changes the economics of running a network. And so therefore, it fundamentally changes the ability for networks to then explode in larger volume. With more complete automation, it enables networks to then be run with fewer experts. You're less dependent on understanding the details of how a device works, and you're more oriented around understanding the greater system and how the system should flow and how services should flow over the system. The service orientation, which is very similar to the service orientation that comes from distributed computing, then enables us to drive a system that's much more automated, much more efficient, and because there are fewer experts necessary, lower operating expense in addition to the cheaper CapEx that comes from Ethernet. Both of these technologies coming together, software programmability and Ethernet infrastructure, enable greater productivity for those that run the network, while at the same time enabling new services and new service flexibility for those that use the network. So all of this working together means that an application-based networking environment that enables anyone to create an application, to run a network in a very specific way, to enable their services to run in a very specific way, can then come to market with a new type of service without the need to have the deep expertise or the heavy investment that it takes to drive closed productive systems in the way we've done it in the past. So all of this drives lower total cost of operations. Today, everyone is looking for lower costs so that they can spend less money on IT and they can put more money into their core businesses to create jobs. As a result of this fundamental change in networking enables us now to drive a better productive network, better productive infrastructure, and to enable new services. So what does this mean? What this means is that what used to be embedded as a part of a closed network system, and I'll give you one example. Today, on any given university campus, there are multiple constituents that use a network. There's students, of course, and students want to use a network in multiple very interesting ways. And those of you that are in the university environment know that every year a new batch of freshmen show up with better ideas. And those better ideas have a tendency to peg the usage of the network until you control it. But on top of the usage of students, you have faculty, we have researchers, we have administrators, we have healthcare professionals, all of them needing the services of that particular network. That network, however, needs to be controlled, needs to have separation of services, separation of different needs and wants for those different constituents. And I think we can all agree that there's a difference in the video diagnosis that's done in an MRI video by a doctor in a healthcare system in a university and needs to have a different priority than a student wanting to watch Netflix. Even though it's video, it needs to be treated differently. The priority is different, the channelization is different, the privacy concerns are different. All of those different types of services yet run over the same network. If you take that and you extrapolate that to a wide North Carolina-wide network, where multiple types of constituents then need to use that network, be they mobility companies wanting to interconnect towers for mobile backhaul, be they universities that want to interconnect with each other, be they state and local governments that need to interconnect to drive better productivity and better access for their constituents, be they businesses that want to be able to then drive better services and export those services around the world. All of those different types of services to date have been vertically integrated. In the world of SDN, we would take the capabilities of managing the healthcare part of that network, or the education part of that network, or the business export part of that network, and explode it into individual applications. Be able to manage the traffic much more efficiently, and be able to provide the right level of access, right to use, security, and traffic management for all of those different types of solutions and services that we provide on the network. As a result of that, we need to provide an infrastructure whereby applications can then plug into the network and allow anyone to leverage that network in a way that's plausible, to manage it not at the level of the equipment, but manage it at the level of the system. To be able to do this, we have now developed a solution called an SDN controller. This SDN controller is what enables applications to provide access applications to provide applications with access to the network, to enable APIs, which open up the system to a standard way of managing that network. And by doing so, we can then get access to all of the equipment that's at the bottom of the network that actually runs the network itself, be they Ethernet, routers, optical gear, any type of equipment that's there, and enable that equipment to be managed in a consistent way as one service. By doing this fundamental reorganization then requires operating systems that are programmable, that are open for downloadability, that don't require experts to touch each and individual component, and enable us to really manage this network as one service network. This is a fundamental change in networking and networking architecture. And as a result of this, this will then enable distributed networking and distributed applications and new services to become available as a part of a service network. That then enables us to drive better productivity. It will enable us to then fundamentally change the way networks are architected and the infrastructure, which will then enable businesses and governments and all the constituents that need access to that to get access to all of the other interconnected constituents in the network. These new types of services, and our fundamental belief is that these new types of services will then drive better productivity. It will drive growth in economics, and it will drive and create jobs and core jobs that then for services that can be exported over the network, not only to other parts of the United States, but also outside the boundaries of the United States as well. And that will drive the hard currency that we need to grow the economy. So we at Extreme are here to expand in North Carolina as a basis for that. Over the course of the past year, we've expanded. We've added key personnel to the original staff that we've had here for the last 12 years. That key staff that's come on board is focused on research and development, customer service, and different aspects of the work that we do in North Carolina. Our expansion here is key to the fundamental growth of Extreme. And Extreme is an unusual company because while we're a public company on the NASDAQ, and we have a very strong balance sheet, over $200 million in cash, no debt, we're actually behave like a startup company. Our work here is a fundamental reorganization of where networks are going. And because we're one of the smaller players in the marketplace, we're investing in the next generation here in North Carolina. So our focus is really to drive a better way for us to do business together. And our focus in North Carolina is to expand our research and development to continue to drive that capability here in North Carolina and with US Ignite to be able to offer this capability around the country and then expand those service capabilities around the world. So I want to thank you very much for your time. I know we have some more question and answer that's coming up, and I look forward to all of your questions, and I'm very happy to be here, and I want to thank you for coming to this event. Thank you.